Question 3, where are the points of discontinuity in function f? And they give us 3 different equations. So at first, helpful to remind ourselves, okay, what is points of discontinuity? Basically, this is where a graph breaks. It's a break in the graph. So that'd be like if we had a piecewise function that looked something like this. So this graph would have a point discontinuity at -1. The graph doesn't exist at that point. So, and that's an important phrase, does not exist, because they don't give us a visual here. If they gave us a visual, it'd obviously be really easy. So the best way to do this is just to take the numbers provided in the problem, substitute them for x, and see if it does not give us an output for y. So for instance, I see a square root symbol here. I know that if we end up getting a negative number underneath the square root, like that can't happen. You cannot take the square root of a negative number and get a real answer. So those are the type of things that we're going to be checking for. And we look at the answer choices, and obviously the choices are either 2 or -2 or both. So let's take those numbers. Let's first focus on -2, and let's go top to bottom. The thing I'll see here, -2 is included in the rule for that top equation, but this graph doesn't exist at -2 because it only exists when x is less than -2. So that means we don't even have to check it because -2 doesn't exist for that top equation at all. Now, if it doesn't exist for this middle equation, then that means -2 would be one of our points of discontinuity. But we can see here clearly, if we take this equation, take it off to the side, and we replace x with -2, well, -2 plus 2 is 0, and you can take the square root of 0 and get a real answer. 0 is an answer. So this graph does exist at -2. Like if we graphed this point, or sorry, if we graphed this graph, it would look something like this. It's a really, really rough sketch, but you get the idea. The graph exists at -2. So that means we can rule out answer choice A, answer choice D. So then this last one, we need to check this one because it says this graph exists when x is greater than or equal to 2. So if we substitute, and we can do this pretty quickly, if we substitute 2 for x in this equation, now you need to check this. Yes, we're going to get an answer. 1/4 times 2 plus 3/2 is going to be an answer. That's going to be, I think, 2. But it really doesn't matter what it's going to be. It's going to be a real answer. So x equals 2 is also not a point of discontinuity because this graph exists at x equals 2. So we cross this out. So that means this graph is continuous. It exists forever.